Hello, everyone. Welcome to today's developer coaching webinar. My name is Tara Van Cleve, and I'm part of the developer relations organization here at Oracle. And today we're excited to show you via live demos how to use the latest AI technologies for .NET and Visual Studio apps with Oracle AI Database 26 AI. I'd also like to note that we are recording the webinar, and you'll receive the replay via the same email that you registered with after the event concludes. If you have any questions, we have enabled the Q&A section of the Zoom and we'll be answering throughout the hour, as well as leave some time at the end for any remaining open questions. Today's webinar will be presented by Alex Kay, Distinguished Product Manager for Networking and Data Access, and Christian Shea, Senior Principal Product Manager, Networking and Data Access. So without further ado, I will hand it over to Alex first to take it away. So Alex, over to you.
Thank you, Tara. Okay, so Oracle database, we've done a lot of great AI innovations out there, starting with 23 AI and up to now with Oracle AI Database 26 AI. And what we wanted to share with you today is if you are a Microsoft developer using .NET, maybe using semantic kernel or Microsoft Agent Framework with the new frameworks for AI, or EF Core, how do you use that Oracle database technology for AI to enhance your own apps, your own .NET app, so that you can use AI with it? And especially now that Oracle database and Oracle Autonomous Database is in the multi-cloud, meaning we're in, of course, Oracle Cloud Infrastructure, but also Google, Amazon, as well as Azure. You have Oracle database available to you anywhere on-premise or in the cloud so that you can use this AI technology wherever you need it. So why don't we begin? First thing I want to talk about is just a little bit of background on Oracle AI Database to if some of you aren't familiar with some of these AI technologies. It will get confusing if I start showing you the demos, I start showing you the code, and you're not sure what a vector is or things like that. So we'll talk about that at a very high level, then start getting into the actual technologies. So Entity Framework Core is one of the big ones that a lot of developers are using with .NET. And then, of course, being able to use .NET vectors, how to develop those with your AI applications, and then incorporating Microsoft SDKs, their AI SDKs of Microsoft Agent Framework, semantic kernel with Oracle Database. How do you do that? And then we'll talk about using the latest Visual Studio with AI in Oracle and Oracle Database. Okay, so let's start with AI Database 6 AI. So the database we've not really re-engineered, but we've augmented significantly with a lot of AI technologies. And it's quite critical because the database, especially relational database, is where a lot of your corporate data exists. And what we want to be, what we set out to do to help you AI-ify your database is use your existing data and be able to use all the latest AI frameworks, and especially with .NET, but also Java and Python and whatnot, be able to use that to do things like vector searching, so you can do similarity searching, be able to use retrieval augmented generation so that you can not only use your LLMs that you want to use in your company or your organization, but as well as incorporate that private data in your database. And that's what kind of distinguishes why you want to have AI in with your existing data, is because you want to AI, in order to function, needs data. Without data, AI is pretty useless. It's smart, but it needs data to be able to give you analysis. It needs AI to give you results. So by being able to use that rich set of data already in Oracle database and use existing AI tools that are in .NET and Visual Studio, you'll be able to do that. You'll also be able to create those vectors for vector searching with the Oracle AI database, with creating things. We have Onyx there inside the database, so you can create vectors with Onyx. You can also perform natural language search, so that if you have someone who's not familiar with SQL, they can do a regular language query of the database and just ask it a question. And that question will get translated into SQL on our side. But for the end user, they don't have to know SQL in order to ask those questions. And of course, we're incorporating all those technologies and tying it into .NET AI APIs, not only fundamental Microsoft extensions for AI, but also the agent framework and semantic kernel as well. And if you're doing machine language pattern matching, we have over 30 machine language algorithms available. So a lot of capabilities. let me get more into vectors themselves because they are a fundamental part of how you use AI with the Oracle database or in any database, I should say. So what vectors are, if you remember your mathematics back in school, they are just a sequence of numbers. You can think of it as an array of some sorts. It could be a multi-dimensional array as well, but it can be an array of numbers. And we call those sequence of numbers dimensions. And those numbers are a way that a computer can quantitatively uh, represent the semantic content of any type of data. That could be a document, an image, or video. And what a developer will do is turn that document, that image, that video into that vector. And Oracle database has vectorization functions built in, but of course you can use other vectorization functions as well. And there's different ways to convert it into different types of vectors, but that's the basic concept. And what Oracle 26 AI does is natively stores those vectors and allows you to do similarity searching on those vectors. So the key difference between kind of pre-AI, which was more exact match searching, and with AI now is much more like similarity searching, where if you want to know about, give me all my content about bicycles here. Now, if you have the term bicycle, it would probably show up in a document about bicycles, but it may not necessarily show up. Maybe in the metadata it'll show up, but if you just have an image of a person on a bicycle without any description, the AI will be able to pick up on it and say, hey, this has a bicycle in it, so maybe I should return it. And this video has bicycles in it, so maybe I should return it as a similar result. So you get this similarity results where maybe you don't get exact matches, but you get a ranking of how similar is this result to what my query is asking. So that's the importance of when it comes, as well as things like being able to use natural language to talk to you as an end user. But that's one of the key things about using it with databases and using it with your data is that similarity search capabilities. Now with vectors, there's a couple types of vectors out there. And this will be important for you as a .NET developer to be able to work directly with these vectors to build these applications. So one of the two types of vectors we have are dense vectors and sparse vectors. Dense vectors are your traditional vectors. Traditional is in the sense that this technology is only a few years old. Or actually it's older than that, but where it's become more mainstream, it's only a few years old. So these are your traditional vectors. It just stores all your data as zero and non-zero dimensions. Then you have your sparse vectors. Sparse vectors eliminates all those zero values, and it really helps in the cases where you have a lot of places where you have a lot of zeros, and then you have data and a lot of other zeros, so that you can really compress that data and also speed up your searches. Now, it's not as good for similarity searches, but it's very well suited to exact match search. And so if you have those type of scenarios that you're using it, sparse vectors are very useful for you. And very importantly, ODP.NET supports both types of vectors. The dense vector is the Oracle vector .NET ODP.NET data type, and the sparse vector is the Oracle sparse vector ODP.NET data type. Now, you can use those data types within ODP.NET, which is our Oracle data provider for .NET, is the interface, is the data driver you use when developing .NET applications in C# or VB.NET. But you can also use .NET types as well. So .NET also has arrays, and those are numeric arrays of floats or doubles, and those can represent your vector data. You can also use byte array and binary, as well as strings. But for all intents and purposes, what you just need to worry about is that ODP.NET will just store that data as a vector, and we'll use our own internal format for optimization with AI operations. So let's start talking about how to develop some apps with it. So we'll start off very simply with an Entity Framework Core app, and we can see that we can use Entity Framework Core to use vectors, both dense and sparse vectors, and to do a basic vector comparison, which is essentially a semantic search on the data. So in order to use this, just some background, you have to use EF Core 9 or higher. That's when we first started supporting it. And of course, you need to use ODP.NET 23 or 26 that supports EF Core 9 or higher. So as long as you get EF Core 9, NuGet will figure out that, hey, which version of ODP.NET is the right one, and all versions of Oracle for EF Core 9 and higher supports these vectors. So what are the things you can do with these vectors in EF Core? Well, very importantly, you can use the Oracle vector and Oracle sparse vector types, but you can also perform some similarity searches with it using vector distance in the EF functions vector methods, and that will calculate your distance between the two vectors. And then you can do vector embedding, generating, because you want to convert, say, a piece of text, which is your query, into a vector so that vector distance comparison can be done. So we have that vector embedding, and then also two vector, which converts from one vector numeric format to another. So let's take a look at a demo of this. So in each of these demos, I'm going to create my table. So I have no actual data in my table or my table itself. And it works very much, well, this is EF Core, but you'll find that even the AI frameworks from Microsoft rely very much on the similar EF Core construct, which is you can create a data model within .NET and then have .NET create your database tables, your indexes, and whatnot for you in the database, which makes it very powerful, especially for demos, which is great, especially because then you can build a standalone demo without having to rely on schemas having been pre-built. But we also rely on that here. So each of these demos will start out by creating the tables and inserting the data it needs. So we'll create two tables, one with dense vectors in this demo, and one with sparse vectors. And with that, we'll then insert some data into each table, and then we'll execute some similarity search comparisons using these EF functions. So here we can see we're using Entity Framework Core, and we're going to pull in our ODP.NET data types. Remember, you can use .NET arrays as well, so you don't have to use ODP.NET types, but we are going to use it just to show you some of the power that you can do if you wanted to use those Oracle types in there. So first thing, we'll create some vectors, some arrays. Here we create some .NET vectors, so a short, a float, and a double, and then also a string, just to show you all types of the arrays we support. And then we can then create Oracle dense vectors from each of those arrays. So we can do those conversions for you and have your own native Oracle vector data types here in .NET. Then we'll insert some data, or at least we'll insert it on the client side into an array. So here we just provide a couple of ways to do the insertion. For the first row, we do this same conversion from the .NET vector type to an Oracle vector type. And then here, we just use the Oracle vector types directly. Then that will create the rows. And then here now we actually insert the rows and save the changes. Then we do the same thing for the sparse vector as well. So it's very similar code. Insert a couple rows, and then do the actual insertion here. And then from that, we can perform some queries now that the data has been inserted. So the first kind of query we want to do is we have two rows. Let's see which row is closest to arbitrary vector we give it. And here, we're going to give it this vector 3, 2, 1. And this has three dimensions. They're of data type int8, and they are dense vectors using cosine similarity. So here we can see we use the vector distance to calculate the distance. So each row will be compared against this 3 to 1 value, and we'll see which one is the closest, and we'll return the results to the console, which one's closest. And the rest of this application does kind of different variations of this, but it'll always do kind of this vector distance comparison. But here we're doing it by passing in a variable key1 here, which is a .NET array doing that comparison, consisting of float 64 is also dense. Then we also do cosine as well. And then we also do that comparison also with sparse vectors below. And this sample is part of our documentation so that you can take a look at it, but it's more demonstrative of what you can do with vectors if you want to work with them directly. And let's just run it to see what happens. But we should get that the second row is closest, and the first row is closest, and output a lot of 2, 1, 2, 1, 2, 1, because we perform this operation 8 times in different scenarios, and we can see that the second row is closest to the arbitrary vector we're comparing it with each time. So I wouldn't say this is a terribly exciting demo, but it kind of gives you a way to understand how to use vectors and different ways you can use vectors if you want to work with them very directly in your .NET application. And very importantly, this is EF Core, so that you don't really need to rely necessarily on ODP.NET specific constructs. You can continue using the ORM that many of you use today. Okay, so let's get into something a little more interesting. Let's talk about some more semantic search type of operations. So we did some basic vector comparison, but let's do kind of something a little more realistic in terms of what you would use as a real app out there. And to do that, what we need is to be able to work with some uh, some more in depth with .NET AI functionality. So we've created this Oracle Database Vector Store connector, and this works in both .NET Core and .NET Framework. And what it does is it's an implementation of the Microsoft Extensions Vector Data Abstractions. And that is the way that Microsoft has constructed how to work with vectors, work with AI apps, and allow any provider to then plug into that kind of framework, if you will, so that the database, the Oracle database in this case, can be used as a vector store. It very much follows the EF Core model first design method, which allows you to create a model inside .NET and then have that model be created and persisted as a set of tables, a set of indexes, whatnot. So we can see that when you start the application, you build it, it will create the tables for you. It will create vector indexes for you, both hierarchical, navigable small worlds, as well as inverted file indexes, or a hybrid of them. And you can use regular data indexes as well, of course. This vector store connector will allow you to manage data in the database, as well as do different types of searches. Semantic search is going to be the most popular, but also keyword searches, since even if you are using AI, you still sometimes want to say, just give me these keywords, and we'll allow you to do a hybrid of those two in the future. And this is available for free today on NuGet Gallery. You just go to oracle.vectordata, search for that on NuGet Gallery. You'll be able to find this. And we've had this available for several months now. So you'll be able to use that and build some interesting .NET AI applications. So what is my demo going to show you? Well, it's a hotel search demo. We're going to load some data from a JSON file. So first thing is we have to create a vector store collection using the model class definition. And based on that, the vector store connector you can see here is going to create those tables and indexes in the database. We're using Oracle Autonomous Database in the backend, and then we have to vectorize this data. So we're going to use Onyx embedding generation model, which is in the database. So we're going to generate that embedding for the data. Well, once we've done that, we will upsert the records, and then we'll insert that into the database. So the database now has that data. And then the application will do a search term. So we'll provide a search, and then it'll return the closest results. So the app searches using a vector, performs that similarity search, and presents the results back to the user. So let's take a look at the code and the demonstration for that. So we're going to take a file that's hotel.json, and it's just a list of hotel data. We can see that it's got a name, a description, an ID, a rating, and whether it has parking or not, and there's 20 of them. And this demonstration this code is all on GitHub, so we'll have a link to that to show you so that you can run this yourself and try it out yourself. And then you can use this against Oracle 23 AI or higher database. So what we'll do is we'll insert that, we'll create the database or tables, we'll insert that into we'll insert the data, we'll then do a few things. First, we'll do some exact match searches, just to show you that you can both do kind of this keyword search or exact match searches, and then we'll do some similarity searches. So first, we'll search by primary key. We'll then search by scalar value properties. We'll then do a similarity search with cosine similarity, and then with one with Euclidean distance. In the EF Core demo, we were just using only cosine similarities, but there's several to choose from, not just cosine, but Euclidean distance is another, just to show you the differences. Okay, so let's just take a look at some of the code. Here, we're just going to load our app settings. And then as part of the Oracle.vector data, this vector store connector that we've created, what it allows you to create things like this Oracle vector store and this Oracle collection. And if you're familiar with MVVD, the Microsoft extensions for vectors, you'll see that, these are very similar concepts because they have the vector store connector. They have a vector store, they have a collection. And so that's because we built kind of on that framework, and we've just extended it so that it can use the Oracle database for it. So it should not be anything new. you should be able to use that very familiar set of APIs. They just have the word Oracle in front of it. It's kind of the key difference, but it'll be very similar. And then we'll also extend that too, so that we can expose more Oracle database functionality, because it does allow you to extend and expose more database specific functionality so that you can get more power from your AI applications and your data. So we then create the collection. We create the vector store here. We have a data source builder to connect to the database. And then we'll read all the text, we'll serialize it, and then we'll use Onyx generate embedding to embed it as 384 dimensions of float 32s. And then we'll ensure that the table's created. We'll create the table if it's not there, and then we'll insert the data. And that's it. That's setting up the data. Now let's do some application work on it. So first couple is doing some exact match searches. We'll search for hotels ID 5 and 10. And you can see it uses a very link-like type of querying here. We get async the values of the 5th and the 10th primary key ID. And then we just search through all the hotel values and output the hotels that are matching 5 and 10. And then next, we'll do a search for hotels with a 8 or higher hotel rating. And here we have the rating of equal to or greater than 8. We'll only return 3 results. We don't want to overwhelm the console output and just return it. So you can see that it's very much like working with, say, Entity Framework Core, this interface. And then let's do some similarity searching so that we can provide it a term. In this case, let's provide a single term, city, and we're going to the embeddings were generated for the names of the hotel and the description of the hotel. But we're going to do this similarity search just on the name of the hotel. So we're going to find the names of the hotel that are similar to the word city. And we should get major city hotels here. And so we have generate the embedding from this hotel name search. So it will then generate the same type of embedding and then do the search. Move it over a little bit. Do the search here that we have. And then once it does the search, we just need to output the results. And we'll also output the ranking as well. Sorry, the score is here. The hotel name is here. And then lastly, we'll do a search of the description. So you can ask it or give it a statement. I want a hotel with great views. It'll return the closest match is to items with or hotels with great views. And we'll return the description as well from this. So we'll generate the embedding of I want a hotel with great views, then do the comparison with all the data in the hotel database. Kind of similar type of comparison, but this time with the description embedding instead of the hotel name embedding, and then return the results. And then we just do some cleanup there. So let's run this and kind of see how it goes. So first query was searching for hotels 5 and 10. It's going to load all the data in the database. And we can see search for hotels with ID 5 and 10. You see here we have the Mount Lake Resort with hotel ID 5, and then the Marina Hotel with ID 10. Next, we have our search for hotels with 8 or higher rating. We can see that Lodge by the Sea got returned, Hotel New York got returned, and Desert Dream got returned. So those were the exact match type searches. The similarity searches are returning here. You see that we got 3 hotels, the Paris, the HK, which happens to be a Hong Kong hotel, and a Hotel New York. So it matched the city search term quite well. And we also published the score to see, the lower score means closer match, closer similarity match. This uses cosine similarity. And then we want a hotel with great views. We do a similarity search against the description. And we see here that Lodge by the Sea has the best match. Nature Inn has the next best. The HK has the next best match. So you see that there. And just to show you where the, let's see, I think it's here. Here is where we define the different ways to do the distance function. We do cosine distance, Euclidean distance, but you can do all sorts. Here, let's see. There we go. You can do cosine similarity, dot product similarity, Euclidean distance, Euclidean square distance, Hamming, Manhattan negative product, dot product similarity. So we give you a lot of different distance functions that you can use this with. Okay. Let's talk about the SDKs that Microsoft has for .NET, because a lot of times you will be developing straight with .NET and just using .NET APIs directly, but also it's easier if you use .NET AI SDKs that Microsoft provides. And specifically, I'm talking about Microsoft Agent Framework and then the older semantic kernel. And both those, Microsoft Agent Framework is kind of going to be the successor to semantic kernel. But what we have today, also I'll talk mostly about Microsoft Agent Framework and I'll show you a demo of that. The Oracle.vector data library works today, is supported today with semantic kernel. And we're doing some certification for it for Microsoft Agent Framework. Microsoft Agent Framework is just like semantic kernel, it's an open source SDK. But in this case, with Agent Framework, you can do both agents and workflows with multiple agents, but also with human interaction as well. Build those workflows with Microsoft Agent Framework, which is kind of why it's the successor to semantic kernel. And it will replace the previous technologies of both semantic kernel and AutoGen. And so far, we haven't seen any problems using our Oracle Database Vector Store connector with Microsoft Agent Framework, but we'll do the formal certification, official certification soon. We're going to see a demo of this, and I wanted to just explain a few things that about this demo because it is a little more complex. I mean, it's very simple to use, but to give you understanding, because this is a technology webinar, and you probably want to understand what is going on behind the scenes. What we did was we took the a Microsoft-based example. In this case, it's a web chat example, and we got this from the Microsoft project template, and it uses the Microsoft Extensions AI template packages in NuGet Gallery. And instead of using we modified a few things in it so that it would use the Oracle Autonomous Database for one, but also we're using Microsoft Agent Framework. We're also going to use the database vector store connector because we need to be able to do vector AI operations with it, with the Agent Framework. That's how it can talk to the Oracle database. And then we're also using the Oracle Cloud Infrastructure Generative AI Service instead of Azure. But the nice thing about this is that Microsoft Agent Framework is very plug and play because of the database vector store connector supports Oracle database with it, so that you can be able to use Microsoft's AI frameworks, whether it's semantic kernel today or Microsoft Agent Framework in the future, to use the Oracle AI database. And then the OCI generative AI service is something in the future they will support natively. At least we're planning to do that. Because OCI, we offer very similar services to other cloud vendors as well for AI. We have a lot of different LLMs, OpenAI, Cohere, Llama, Google. So all the major ones are there. OCI AI offers chat completion and then be able to embed different models in the cloud. So we're piloting right now this OCI AI chat, what you'll see here, to do that chat completion, to do that embedding generation with Microsoft Extensions AI. And we hope to have an actual version that you'll be able to use as well. So let me explain how this demo works if you're not familiar with it. It's a very standard Microsoft demo that they published on GitHub. But if you're not familiar, I'll walk through it. So you have a set of PDF documents, and we use the same ones that Microsoft uses. One's a GPS watch, document about GPS watch. The second one's about some emergency preparedness information. And those are in PDFs. So we look at the PDFs, odp.net, we'll look at them, and then we'll say, okay, let's ingest those into the database so that they can be searchable. So we'll update the table so that we can have the infrastructure to ingest them. We'll put that in the Oracle Autonomous AI database. Then we'll take the PDFs, we'll chunk it up, and then we'll insert those text chunks using the vector store connector, and then embed them using the OCI AI embedding generation model. And then we'll upload those chunks into the database table. So now that you've got your data loaded, you can now perform operations on it. And then we can ask it questions using the Microsoft Agent Framework. So on the left, you have your AI web chat app. With the agent, you ask it a question. And agent framework will go and send this user message to the LLM that you want to use. And then it'll decide, do I want to ask the database for some more information, or do I want to response? Well, since we don't have the answer to the question, we are going to ask it, the database, for some information. So we'll do a vector search with that search phrase of the database. So we'll use semantic search using that search phrase. We have to vectorize that search phrase. So we'll use the OCI AI embedding generation model in order to turn that into a vector so that similarity search comparison can be done. And then we'll do that vector search among the chunks and find the ones that are closest in meaning. So once we have those vector search results, we'll return those. The LLM will then figure out, okay, how do I want to word this in a chat so it sounds more human-like, as I've been programmed to do. And then it will send those vector results. Well, send the vector results, and then the LLM will decide what it wants to do. And when it finally turns it into a response it wants, it'll send that response to the user. There. Okay, so this is the last demo. Okay, so we have this application. We're using Microsoft extensions.ai, and we're using Oracle Cloud Infrastructure as well. And very importantly, the Microsoft one uses AI, but OpenAI, but you can use OpenAI, you can use Cohere, you can use Llama, you can use any of them. In this case, as long as the embedding model we're using is the same, so it won't really matter other than maybe the quality of the results, because that's what the different LLMs are kind of competing on, is the quality of their LLM. But in terms of actually running and functioning, any of them will work. And so what we do is we first authenticate to OCI and be able to go to OCI in order to get this OCI Gen AI services. And we have an iChat client and embedding service. So this is just standard set of .NET APIs with Microsoft Agent Framework and .NET. And we're just using that to then get the Gen AI services. And then we use those Oracle collections to then connect to the database, do the ingestion, do the chunking, and then do the searching. So nothing actually too specific to, say, the Oracle database. So you can see that most of the code is just working with the UI, working with handling the input, the user interaction, but the actual connection to the database is just this very small amount of code that you have here. You have your endpoint you want to figure out, you have your services that you want, and then how you work with the data here. And it creates a pretty sophisticated app. So if we start this, it'll load the data to the database, and you can start asking it questions. And you can see that these two PDFs have been loaded, and we can ask it a question like, what should I do in an emergency situation? Even auto-complete it for you. And it'll look in the database at the documents it has. It'll look at the survival kit, and it'll see like, oh, you should ensure you have access to first aid, food, water, shelter, whistle, radio. Okay. And then you can even see the source. They'll put you the source where here's the safety precautions, where it comes from. And then what should be in my first aid kit? You can ask another question. And it'll give you a list of things you want to be in your first aid kit. Is a GPS tracker good to have in an emergency? Because we have two documents loaded. One is a GPS smartwatch that we have. So GPS watches, and you can see that instead of just survival kit information, it can also look at the other document it has, because the survival kit didn't have any information about GPS watches, but the GPS watch PDF does. And so it returns information about the GPS watch tracker is good to have because it allows you to run current location. So you can see that it will also suggest questions for you. How do I use one? And then it'll answer that question for you. So this is very much a cool way that you can get quickly started with, say, building an AI app with Oracle database. And it's something that we are planning to have with the Oracle Cloud Infrastructure soon. So that kind of gives you a whirlwind tour of using ODP.NET, building a .NET app. And I want to turn this over to Christian.
Hello, everybody. We're going to talk about Visual Studio integration now. I'm Christian Shea. I'm product manager for our extension for Visual Studio. And let me tell you a little bit about that for those of you who aren't aware. If you are doing a .NET development in Visual Studio, you should probably know about this because it might make your life easier. We do have a free extension in Visual Studio. You just go to the little extension marketplace menu option at the top of the screen and install it from there. I'll show you how to do that in a second. And what I'm going to do is I'm going to give you a demo overview for a few minutes of some of the features of this. And then we'll move along to Select AI using Select AI from Visual Studio. So any case, as you can see here, you can explore your database, manage your autonomous databases, use designers for all the different object types like table designers and procedure designers, if you so choose. We have PL/SQL editing and debugging and SQL script editing and schema comparison and script generation and such. So let me go on and give you a quick demo of what we have available. So right now I'm using Visual Studio 2026, so can you, of course. And I just wanted to mention that some of the features I'm showing here, for example, Select AI, are not available for another a month or so. So if you want to try this out, you'll probably have to wait till the next release. So you're seeing kind of an early demo of some of the functionality that we're going to have. Now, this extension is available right now. So you go to the menu, say Manage Extensions, and search for Oracle. And I think Tara has a link she'll share in the chat if she didn't already. And you can look at the web page for that. But generally, you'll install it right here from within Visual Studio. Okay, so once you do that, Server Explorer will be enhanced to include, among other things, a cloud node. So you can see here that I have a couple of ADBs, including the one I'm going to be doing my demo off of today. And let's look at the kind of things you can do from here. So you can start your database, stop it. You can create one, of course. Up in here, if you go to the root node, you can create a new one, and the individual ones, you can see all the different things you can do. So I want to connect to this. So one thing that's really nice is, normally you'd have to go and hunt out the connect string or get a wallet or whatever you're going to do to connect to this database. But we make it really easy. We have a create data connection dialog. And this basically gets the connect string for you and populates a connection dialog. So let me log in here. And let me change the name so it's a little bit better than just the whole connect string. How about select AI demo? All right, and let's test the connection. It worked. Let's connect. Okay, so now that we're in here, you can do all the kinds of things you would expect. You can explore your tables. You can look at your packages and your procedures. And right, so for example, with tables, you can edit. You can double click on a table and view the data and edit it. As I mentioned, we have designers for each of these objects. I'm not going to have time to go to all these things, but and show all of these. But you can create a new table with a designer, etc. Okay, so I showed you the package here. So if you're working on PL/SQL, you can double click on the package name and you can edit it directly in the database. Um, this is kind of a null procedure, but you could edit it right here inside of the database. But most people are not going to do that. They're going to write their own SQL and SQL scripts and run that. So let's show how to do that. So you can right click on this and say, open new SQL file. And then I can just say select from EMP, and then you can see that it has IntelliSense. I just hit tab. I can hit the space bar here and come down and select all columns. I can use the formatter. We have a formatter built in. Um, yeah, so then I can execute this, of course, click the execute button and look at the data. Um, so the IntelliSense is pretty nice. Let me show you some other aspects of the IntelliSense. So for example, I showed you that little procedure I had in the test pack. So if I hit dot, it'll show me that, hit tab, and look at that. It auto completes the signature for the procedure. And all you need to do is just replace these. And another thing that's really great is if you're doing things with aliases. So for example, suppose I say select from employees, E, E, departments, D, and hit the space bar, and let's say E, all columns. Okay. And then I can, let's see, delete a few of these. Okay. I think I got a little aggressive there. There we go. And then I can say, let's say D dot all columns. Let's format again, get rid of some of this stuff. I just keep department name. Okay. Got a little bit of fumble fingers here. All right. And then get rid of that comma. Now, one thing you'll notice is if I hover over column names or over aliases, it tells me the metadata for those objects. So it's real nice. All right. Now let's add a where clause where D dot department ID equals E dot department ID, something like that. I don't even know if I made a typo. Nope, it worked. So I think IntelliSense is one of the really great features of this functionality here. So with that, that's the whirlwind tour. Obviously, there's a lot of other features here. If you just look at the menu here, I think I'll zoom in a little so you can see. You can just see all the different things you can do: real-time SQL monitoring, schema compare, performance analyzer, generate, create script. The list goes on and on. This is a fairly mature product. We have a lot of features in it. I'm going to come back here in a few minutes and do select AI from here. So let's go back to the slide deck. So surely by now, and don't call me Shirley, as they say, but surely by now you've heard about Select AI. Oracle talks about it a lot. But if you haven't, basically it allows you to do natural language queries in the same place where you would do a normal SQL query. So in order to do this, you're going to need to choose a LLM that's available to you. We support a wide variety of them, not just these four, but a wide variety of LLMs, including OCI, Generative AI, OpenAI, and Cohere, and Azure. And then you're going to need to create credentials to allow the database to know how to connect to that LLM. And then you're going to need to tell which schema information is okay to give to the LLM. And finally, you do your query. And the way you do a query is select AI question. Now, that actually generates the SQL and executes it, which is not really a good idea. It's always a good idea to ask the LLM for the SQL and then validate it and make sure it's okay before you execute it. So basically, the workflow looks like this. You ask a question. It has a profile associated with your session, which you're going to set, and I'll show you how to do that. And basically, there's database metadata, the LM that's going to be used. You generate the SQL through the LLM, and then you either get the query back or it's automatically executed. So let's go ahead and take a look at a demo of that. Okay, so let me delete what we were doing and go to the menu here. You can see that there is a Select AI menu. All right, so this is how you get everything set up. You can do it all through calls to DBMS. I think it's DBMS Cloud AI. It's a package. You can do it yourself by following a blog, but this just makes it much more convenient. Okay. So the first step, which I'm not going to actually, well, actually, the first step is to configure. You only do this once, and it's basically to tell the database, yes, it's okay to connect as my user to the LLM. This is what the SQL looks like, and most likely your DBA will be doing this since it's a DBA related task. I've already done this. I don't need to do it right now. The next thing you're going to do is you're going to uh, configure a profile. Okay. There's a menu again. Now, before you create the profile, you actually need to have the credential. So we put them both on the same page, basically. So you have a connection and a username, and then the credential name. Just a moment. Zoom is hiding me again. Let me. Okay. You can see that there's various types of credentials. So you can use OCI, you can use a password. Um, so um, I did what I did was I used Cohere in this example. So I just used my username and a token. And I already did this, so I don't need to do it again. But this is what the SQL will look like when it's executed. Okay, so now we're going to get to the part where I'm actually going to do something. So we're going to go over here to create profile, and I'm going to create a new profile. Let's just call it select AI demo to be creative. Now I only have one credential. I created it earlier. I'm going to be using Cohere, and for the name of the model, I'm actually going to use a different model that's in the list here because in this particular beta software, we don't have the one I want to use, but you can hand type it. And then the key part here is to tell the LLM which objects you can use. So this is the key part. So I want to tell the LLM that it's okay to get metadata for all of the tables that I have in HR. Okay, but you could pick any individual ones, views, materialized views, etc. Okay, and that's it. So let's look at the SQL it's going to send across. So you can see it's doing a create profile and it's providing the metadata information. All right, so let's save this. Okay, now the last thing you need to do before we can get into the demo is you need to tell it which profile to use. So right now I have no profile chosen. So I'm going to say, find the one we just did, select AI demo, say save. And now whenever I open a new SQL file and it connects, it's going to issue a simple little command that's going to set the profile. So now I'm using the LLM I want, and I'm using the metadata I want. So now let's go ahead and issue select AI show SQL. This is important because you don't want to just do select AI or it will execute it. So let's go through these here. So what are the departments and where are they located? Okay, so we'll execute this one. And the value is truncated, but I can click this little button here to show it. And this is the SQL it wants to execute. So is this okay? Department name, it looks okay to me. It's not dropping tables or anything crazy. So we can execute this. And you can see that it returns the department and where it's located. Let's do another one. Select AI show SQL. What was my next one? Rank the departments by how many people work in each department. I've got this automatically going to clear screen when I execute, but that's completely an option. Um, okay, so here is the SQL for that one. And I suspect that, yeah, let's take a look at this. That looks reasonable to me. A little bit convoluted, but we can execute this. You can say execute, or you can click the icon. There we go. So there's the employee count, there's the rank, and it kind of goes down the list. And the last one, let's see. Who works in the IT department? Okay. And here's the result. Maybe I'll use the formatter just because I love it to look pretty. So yeah, this is the SQL they recommend. So let's execute it. And here is the workers who are in the IT department. And that's about it for Select AI. So, like I said, this particular feature is not yet available from the marketplace. A lot of the others are. We're doing a whole big revamp of this product to make it nicer. So I highly encourage you, if you're interested in this, to, as soon as you see the next release drop, which will be in a month or two, to grab it. So with that, we'll turn it over to Q&A.
All right. So thank you everyone for all your great questions. And if you enjoyed today's session, this is an ongoing series. So if you'd like to find any of our upcoming events, we do it pretty much every week. That can be at oracle.com/developer/events. And on that same page, we have a link to our YouTube playlist as well that has every single replay in the series. So great content resource there. And then lastly, we would love to hear any feedback that you have for us on today's session, on what you'd like topic-wise going forward for the rest of the series. So you can grab the link here, but it will also pop up as you exit the Zoom today. So just a quick survey, and we'd love to hear from you. So with that, thank you again so much for joining us here today, and we hope to see you at the next one.
Bye-bye.
Thank you,
Thank you.
everybody. Thank you, Tara.
Thank you.